Hello everyone, today we're going to talk about the simplest oscillator system, and it is called by the simple harmonic oscillation. So this is very simple and I believe you can understand this. Basically the system only consists of one point of mass that is moved along back and forward along a straight line. Okay, so the system can be modeled as spring and mass. This is mass and this is the spring with spring constant K. The spring constant shows how stiff or not stiff is this spring. Okay, because you remember every oscillator should have stiffness and inertia characteristic. Now, we want to find the mathematical model of this oscillator. We want to find the equation of motion. To find the equation of motion of this system, we have to look at the force. But first of all, you might ask, how can this move? How can this oscillate? If you think about that, that's great because this diagram doesn't show an oscillating system. We have to do something to make it oscillate. Okay, I have to give it a displacement. Like imagine if we again put our hands in here and then we pull it right there to this position. So you can imagine that the spring is stretched like this. Okay, and then you release the grip. Oops. The mass will move here, and then the spring will compress like this, and then it will move here again, here. So the system is oscillating. Okay, I will draw it again so you will not be confused. This spring and mass could oscillate if there is a displacement. Let's call it as x because it is in x direction in this diagram. Okay, now like the previous explanation in here, the mass is moved to this way, okay, because of the displacement. So the mass feel a force in this direction. Let's say force 1, F1. But when it has a displacement x, the spring is stretched and it wants to get back to the initial condition. We can say that the spring has a restoring force to this direction, and it is called F2. The system is in equilibrium state, so these two forces in opposite direction can be equated as F1 is equal to F2. Now we have to find what is F1 and what is F2. I'm gonna assume you have this theory before. For F1, let's take a look at the Newton's second law. In the Newton's second law, if a mass move thing, it will have a force that is equal to the mass times the acceleration. And then here, the acceleration is the second derivative of the displacement, or x, with respect to time. While the F2, the restoring force of the spring, we have to remember the Hooke's law. And the Hooke's law, we know that the restoring force is equal to minus k times x. So this is equal to this. And if we divide the whole equation to m, then we're gonna get the second derivative of x with respect to time is equal to minus k over m times x. This is the equation of motion for this system. This is the mathematical models that show how this system vibrates. I think that's all for today. Thank you for watching.